Welcome, learners. Today we have Dr. Kiran with us. Dr. Kiran is a partner GM at Microsoft, and he leads the data sciences and machine learning innovations at Microsoft. Delighted to have you here, Dr. Kiran.
Yeah, thanks. My pleasure.
So, Dr. Kiran, to start things off, can you walk us through your journey in the field of data science and machine learning, and how you ended up being a partner GM at Microsoft?
Yeah, see, actually, my experience, starts with software engineering. I started out as a software engineer with Motorola. I'm a computer science engineer. I've done my master's in management, and I have a PhD in recommender systems. And then I started out my my machine learning career and data sciences career with Dell in the e-commerce space. So at Dell, this was the mid 2000s. Dell was the most admired company in the US, and then I spent like a good 6 years there. At Dell, I actually did a lot of data sciences and machine learning for their consumer business, which is like a $12 billion business. And in those days, I must say that the term data scientist is fairly new. In those days, we call all of this as analytics. It's only recent times that it is only the last 10 years that the term data science has taken off. It existed as
Just curious, what was the designation back then at Dell?
I joined Dell as an analyst. Then I became it was more, you used to call it advisors, analyst advisor. Then I became a manager, and from a manager I became a senior manager. So my growth path there was joining as an analyst advisor, and then going through the ranks to be a senior manager. And I've been through the ranks person, like bottoms up, hands-on, technical. So there are two types, right? There are one type of leaders who do a lot of things like sales, marketing, other business functions, and then do a rotational stint here versus somebody grown up here, right? And there. From there, I had stints in e-commerce. So Dell was e-commerce for me. So Dell, I would say the first part of my career, Dell, Amazon, Flipkart was e-commerce. Then I went to VMware. And VMware, I did, at Amazon, I headed up affiliate data sciences. At Flipkart, I was one of the early employees, helped set up the data. I was one of the interviewers for setting up that machine learning function, very early days when they had that Koramangala office. And then VMware, I set up the VMware's data sciences and advanced analytics function in India. And then next, the role became global in scope, right? I joined there as a senior manager. Then the growth path was senior manager, director, senior director, and spent like a good 7 years in VMware. VMware, very different from my earlier companies. So I put them Dell, Flipkart, and Amazon as e-commerce. VMware as R&D product ML. And the last 2.5 years, I've been with Microsoft in their cloud data sciences practice. Here I joined as a partner GM. So I have been very passionate about machine learning, both at work and outside of it. I'm very usually, as people go into leadership roles, they become less hands-on. In my case, it's been the reverse. I've been more and more hands-on over the years. I've built up. I get a lot of joy building up complex systems. There have been like one of the things I would say is that is that my key to success, my key to whatever little success I've achieved has been very strong execution, a lot of passion, and trying to innovate a lot. I've been very fortunate to have won the Innovator of the Year award from Michael Dell in person, won the C2 award in VMware. I have like 31 granted US patents. And then even outside work, even when, I like to, even outside work, there's this competitive data mining platform called Kaggle. So I'm the first Kaggle Grandmaster from India. So there are some folks here, but they probably will not know me because I was like the 2013-12, right? They were like probably 15-20 grandmasters worldwide then. Now I think there are possibly 100 competitions grandmasters. Won the KD Data Mining Cup one of the years. And then I also like to teach. So I teach some courses in IIM Bangalore with the Data Center Analytics Lab, and also with IIM Lucknow, which is my alma mater. So my background is that I'm very passionate about this space. And then as a leader, I like to have the right culture and environment for data scientists to succeed, right? Because what I found is when I grew up as a data scientist, ML scientist, it's very uncommon to have a ML sciences leader, right? So, and then I also want to do something good for the ML scientists. So I'd like to have the right culture where ML scientists can succeed and do well.
And so we know that you're an expert at MLOps, right? So when is it that your love with MLOps started?
See, MLOps, what happened is, I would say that There should be a very strong part to production for models to succeed, because ML should do one of two things: tell people what they don't know, or drive revenue and margin for the company. There should be some value add, and this value add comes when somebody adopts the work. See, many times we have seen that ML models get developed, but they don't go to production. So the way to bridge that is through MLOps. So that's how I got interested in MLOps. And initially, I remember we were all on what was called the V1 of MLOps many years ago, right, mid 2000s. People would build models on two places. One is on their laptops, and then keep it in folders which are IT supported, or build it on virtual machines. The idea is that when you go home, see, before if you look at early 2000, the concept of laptop was also not there. People would work on desktops in the office. When I was working in Motorola, you can't carry the desktop home, right? Then when you worked in Dell and other places, you used to get laptops which you'd carry home. And the idea was that from home you log into a virtual machine in office, remote desktop in the office, and do your work. From there it went to the virtual machine concept, right? And then IT supported environment was there. And then but then what happens when you have all these environment, right? In the first environment, run into trouble where somebody wrote something in a folder not IT supported, and that folder computer crashed, data gone, right? The first trouble you get. When it is IT supported VM, you face another type of trouble. You build some model, it gave results in dev, in the lab good results, production total failure. Why was it a failure? MLOps issues, data quality issues, like the database which was used in production was not the mirror image of dev. It had some different representation, or some of the data was missing, or the systems were not in sync, or maybe the hyperparameters that were used to get the optimal results in dev were not used in prod, right? The results were not exactly reproducible. The models were failure because some of the assumptions that we made in the test environment regarding the arrival of the data or the way the systems worked, they were no longer valid in production. So that got me curious. It's my point to see, when I was heading the teams as a senior manager, as a director, as a senior director, it was very important for me to ensure that my team is successful. And as leaders, we also play an important role of getting investments for ML work. So if the ML models don't generate any impact, or the impact path is not clear, people ask questions. Hey, what did you build? Why did you build it that way? Right? So that's what got me interested. The dev prod reproducibility. Dev and prod should be mirror images. Environment reproducibility. Checking for drift. Sometimes the model was working great 2 years ago, now the model is not working. So all these are MLOps things, the reproducibility concepts. Then the dependencies on engineering. Like, see, suppose I build a model, I am dependent on you. I'm building a model for you. Let's say that you're going to use some model. Now, for me to get value, you have to integrate it into your system. Suppose you delay it and say, I'm having a lot of, see, you are also selling a product. Let's say he's our consumer of the product. He says, I want so much revenue coming. You will say, Kiran, if you put your feature, I'm getting this much revenue, I want more revenue. So then what happens? You'll deprioritize my feature. So I can't have a part to production because I'm dependent on you to integrate my code. But if you expose my work as an API that you can call and get results, then I don't have the dependency on you. You can say, it's very easy for you to just call this API and do it. So then, the path of production becomes much more efficient. And over a period of time, you'll have a lot of nitty-gritties. Like, see, there will be 60 models, 70 models running, and then, any of the model can fail, anything can happen. So in these cases, it becomes very valuable.
Absolutely. And a great overview about the things we have to struggle with at MLOps, right?
Yeah. It's a big struggle otherwise to generate impact. And then when you have dependency on other systems, it's a challenge, right? Because dependencies are real, prioritizations are real challenges. And then, getting people skilled at all these things is tough. See, many times ML scientists, they get stuck. See, one of the things I want to tell the ML scientists also is it's important to have multidisciplinary skills. You suppose you want to onboard a system. If you're dependent on IT engineer to do it, you're creating unnecessary dependency. Learn SQL, do it on your own. If you want to move from a Synapse product to Azure Databricks, right? Databricks is a better product than Synapse. Then you need some engineer to go and do it for you. Somebody else. Why have these dependencies? So build the skills so that you can be more effective and generate more impact. Yeah.
That makes sense. Particularly, you mentioned about reproducibility, right? So could you share some of the best practices, particularly for reproducibility, when we talk about large data sets and in cases of distributed computing?
Yeah, see, some of, like I said, when we look at reproducibility, right, the first part is dev prod pipelines. The development and the prod pipeline should be mirror images of each other. When data scientists, we create code, what is the normal way we do? Create data set for training, validation, scoring together, right? Create one big data set, then from it you take some portion train. Time-based validation means first n rows train, next m rows valid, k rows score, and then we build the model and score it. But putting it to production is very difficult because the production time, you're not, every time new data is coming, you're not scoring the full model process. You're only scoring the new data. So if you don't build the system such that we can score only the new data in an effective way, when we want to put this model to production, everything has to be rewritten. Like we have to rewrite the data pipelines, and then many times the data pipelines may be written by another team. That team may not understand the data, then everything is broken at production, right? So when data scientists write code, the concept of a dev and a prod pipeline has to be there. Dev meaning you're training, validation to get the results. Prod means the system model is already there and new data is coming in, it is getting scored. That's the first part. The second thing is environment reproducibility. Today there are so many software versions and so many dependencies. When the software version changes, sometimes they will tell like this, right? In pandas, or some package, any package will tell. In this version, it is a warning. Next version, it is an error. So if you're in the next version and then you try to run it, fail. Or some packages will be not compatible. They'll say this version is compatible only with pandas less than or equal to 3.6. Went to 3.7 in prod, it will break. So it is very important to have the environment reproducibility. So the good thing is, to whenever we do anything, some basic things we can do is when we start to write code, create an environment using the Python command, right? If you're writing Python code, write everything in the environment. When we share something with another person, don't share code files or GitHub files, share the Docker container, right? The Docker container which the other person can pull from the registry and run it. So that's about that piece. Third thing is being very cognizant when we build models about different aspects. Like since you asked reproducibility, right? Like for example, the results that I get should be the same as results you get. Suppose I get result of 99.4%, you get result of 98.9. I cannot tell that it is due to chance. How will you verify that I indeed got 99.4? So I should use store all my random number generators, their seeds, so that when you run it, you get the same results as mine, provided the conditions are the same. The other thing is, when we tune, we can build, everybody uses the same techniques. But if you look at some last mile competitions like Kaggle, same algorithm, different people use the same textbook, everybody read. Somebody got 100 marks, somebody got 50, right? Somebody failed the exam. So same model people are using, people are getting different results. So the hyperparameters are different. So to have the right hyperparameters tuned and stored so that the other person is getting the same result. So these are some things we have to do from our coding perspective when we write stuff, writing it in a reproducible way. These things this is what we can do from our perspective. And then it's also very important, I would say, is to have a lot of this data reproducibility. Like many times, see, we have to store a snapshot of the data also. I got the results from this code with this data. With another data, we may not get the same result. Right? And then taking a very hard look at the data quality issues. Like see, sometimes missing value comes, replace everything with, somebody replaced with mean, somebody did median, somebody thought I'll impute with some Bayesian method, somebody just replaced with minus 999. But to understand what is the reason the value is missing, why it is missing. Suppose salary is missing, we put somebody's salary as minus 999. This is bad. No, you cannot do like that. You can impute with the mean. Something else may be better. Zero may be bad, infinity may be bad. Suppose that record that you're imputing missing is Michael Dell's salary, then your model is gone for a toss. You have to be very, very careful, I think, right? Even in framing the problem, how the model is going to be used, all these things you have to take care. Whereas reproducibility, right? Each of these parts plays a very important role in the reproducibility.
So in our discussion earlier, you mentioned about drift as well, right? So can you share some insights on how do we monitor drifts, whether it's concept or whether it's data drift? How do we monitor anomalies and the degradation of models over time? What are some of the good monitoring methods to evaluate these?
So if you look at data drift happens when the distribution of the data changes. So the data distribution can change due to a variety of reasons. So one simplest way is to keep track of the mean of the different variables. If the mean or the median or the standard deviation, mean is like the average. Standard deviation tells you about the volatility. So
one follow-up question related to that is, let's say when we are taking mean, right?
Yeah.
And we are getting new values.
Yeah.
It will take a long time for mean to change, right? If you have tons of values.
There are ways in which one can use some alternatives to mean. So the problem with anything which is an average is that average is slow moving. But if you look at the world of signal processing, there are different types of filters available, like Laguerre filters, right? Like band pass filters.
Would Kalman be relevant? Would Kalman filter be relevant over here?
Kalman filter, see, any type of filter basically does a moving average with some smoothing, right? I don't know about, I have not used Kalman filters, but the filters that I've used are band pass, high pass, low pass filters that allow you to allow a certain range to pass through. So you can try Laguerre filters because they will react very quickly. If you look at stock market also, stock market analysis people, the famous is the moving average crossover, right? Short moving average, long moving average, short moving average crosses long moving average, buy. But if you do that, always you lose money. You lose money because it's taking a lot of lag. So if you look at it, a lot of this signal processing can be used there. But typically on data drift, other way you can do it is by ML model. So today in deep learning systems, you can create something called autoencoder. The input and the output are the same. You pass it through a series of layers. You take the innermost layer and treat it as a signature for the data. When there's new data that comes in, pass it only through the encoder, go to the innermost layer, do a cosine similarity, and then say that this data signature has changed, therefore it is a drift. Okay. Model drift is when the model performance changes. So the simplest way, like a moving average way, is to look at the performance of the model through multiple runs and say, is the performance degrading? The performance may be degrading because if multiple reasons, right? Maybe the data that is coming in, the distribution has changed. There are more features that can be used. The features that were relevant in the past are no longer relevant. I'll give a very practical example. Many times when products are launched, who buys it? Enterprise products. Big enterprises will buy. Why? Because they give it free. I want some customers. I'll say a big customer, free for your use. Then once you use and get number of users, I'll say free till 50 users. Once you say 50 first user, I'll say pay the bill. Right? So then that's how it works, right? So first enterprise customers will buy. So when we build a model, initial stage of the product, it will work well for enterprise, bad for SMC. Later on, when SMC starts to buy, it won't work. There's an example of a model drift. One way to test that is through a backtesting framework, where every time model results come, we test it on the last. See, suppose I say, let's take an example. Let's say I predict beginning of the month in the Nifty 50, which 5 stocks are going to go up. I could tell you, see, ITC will go up, Reliance will go up, and maybe, ITC Reliance will go and IT stock will fall, Wipro will fall, Infosys will fall. After 1 month, you can check and say, what Kiran said, did it work or not? That is backtesting to detect the model drift. Concept drift, is basically when the concept itself is changing, right? Like sometimes this we get the feedback from the impact assessment module. Like, the business won't be taking any action. The business will say that, we said any customer more than $5,000, good customer for us. But then $1,000 is somebody want to target. The business changed it to 10,000. Then they're not using the results. Then we know it is not working. So drift can be checked in these different ways. There's a lot of innovation possible on the MLOps side. Like, one can use deep learning systems, reinforcement learning systems. And the thing is, a lot of things have to be stitched together to make it a platform. And, it requires a lot of effort, that way.
Oh, interesting. That's definitely going to give us some insights onto checking these drifts.
Yeah.
So again, I know it's not as you knew now, but MLOps was, it's a very hyped up topic, right? A couple of years back, it was being covered everywhere, right? Which also led to a lot of myths about MLOps being coming out.
Yeah.
Any particular myth that you would want to bust about MLOps?
See, what happens is, typically, people want to do things that are cool or seem cool to them. They don't want to do things that were uncool. So one of the myths that has happened is that MLOps is like, what do you say? The way people look at some of the people look at MLOps is like, hey, if you couldn't make it as an ML scientist, you made MLOps, right? Which is not true because, for example, I have done a lot of things which are, I manage ML ops along with applied ML, and I actually find it more difficult to hire good ML ops people than applied ML people. So the thing is, people have the feeling that one is that it is not the glory or glamour work is not there. Second is it's very mundane with no opportunities for innovation. So I can say that in the last couple of years that I've been driving MLOps for Microsoft Cloud Data Sciences, there have been 4 or 5 patents which have been filed on MLOps. So there's a way for us to innovate. So we have to find meaning in our work. And unless we find the meaning in the work, we won't be able to realize the value. Yeah.
So lastly, any tips for our learners who want to get into the field of MLOps?
See, one thing is, today's world, we are very lucky because there are so many resources available for learning, right? So one of the things I would say is I've been very impressed with Analytics Vidhya's material. Like after a long time, last week, I have used a lot of the gradient boosting methods. But like GBM, I had a lot of iterations that happened to the module. I want to know, like, hey, what are some of the ways you can tune or some best practices searched. I can say the Analytics Vidhya article was very good. So I would say that if you're doing Analytics Vidhya, it's actually a great thing. They got a lot of great resources. So I would say that MLOps, anything else, go to Analytics Vidhya first, find out what is there. Then books wise, see, there are a lot of books available. The challenge is that you have to read several books to synthesize the knowledge. So I would say that it's better to go with somebody like Analytics Vidhya, who's they're offering a course, refer to the material, refer to some Coursera courses maybe, and then also read up about. See, other thing is, when you look at MLOps, also look at what are the grounding skills for MLOps. If you don't know Python, don't know SQL, you can't do any MLOps, right? You need to learn those skills first, right? That's what I would say. Like, look at it as learning, and always, always the first thing is, it's we who make our job interesting. There was in the they say that if we don't find meaning in the work, we expect the work to be glamorous. As per our view, we can't learn anything. First, let us learn. Then let's see what we can do glamorous. Yeah.
Very interesting and very valuable advice. So thank you, Dr. Kiran. Thank you for taking out time for this wonderful discussion. I'm sure our learners and students will find this very, very valuable.
Thanks. I appreciate all you do for the community. Okay. Thanks a lot. Have a great day. Yeah.